Hello, welcome to today's session. Today we are looking at the UTME Mathematics 2016. So we're starting from question number 1, and question number 1 says integrate 2x cubed plus 2x over x. Integrate 2x cubed plus 2x over x with respect to x. So solution, we have 2x cubed plus 2x over x. All right, with respect to x, we are to integrate this one with respect to x. So as you see, this is under integral calculus. I'm just going to give us a bit of introductions to it. So if you want to have an in-depth knowledge of it, you can go to you can refer to our subject by topic area, where you have an in-depth knowledge of it. But I'll still give you an introductions to what an integration is, and so that you can have a background to solving this question. So you know that in integration, if you have what we call a function of x dx, okay, which is something like let's say we have x raised to power n, and then we are differentiating this with respect to x, where n is the power of x. This is equals to x raised to power n plus 1 over n plus 1 plus a constant k. Remember that your integration is the opposite of your differentiation. It is what we call anti-differentiation. So that's why the constant is there, because if you have a constant, if you have an equation, say like 2x squared plus 4x plus 5, and then you differentiated it, this constant will not be accounted for. So when you are integrating it, trying to get back this equation, you need to put a constant there to account for any missing constant from the initial equation. So that's why we have the k there. Now this equation, very equation, is a joint equation. I'm going to split it. So solving this equation, coming back to our solution, the initial question, I would split this into 2x cubed over x plus 2x over x, then all the x, okay, which can be written thus as 2x cubed over x dx plus integral of 2x over x dx. So you are having them individually. So this can also be written thus as equals to, if you cancel this one, cancels one out of this, so you have 2x squared dx plus this cancels this, then 2 dx. Okay, now this is equals to if you apply this formulae up here, then you have your solutions to be equals to 2x. You have 2x to power of 3, that's 2 plus 1, all over 2 plus 1, then plus k, that's, you can have that constant there, plus the coefficient of 2 here is x raised to power of 0. Remember in mathematics that any number to power of 0 apart from 0 is what? Is 1. So we would assume that 2 is the same thing as 2x raised to power 0, such that when we integrate it, we are going to have 2x raised to power 0 plus 1 all over 0 plus 1. So this invariably will give us 0 plus 1 is 1. So we have 2x, 0 plus 1 is 1, so 2x over 2x. So now if we integrate that, this is actually the integration. Now, so we have the solution to be equals to 2x plus k. Okay, now let me clear up the screen a bit so that we can have space to ourselves. Clear the screen a bit. Okay, now what we're saying is this is equals to, by the time you integrate it, we're going to have 2x raised to the power of 3, because 2 plus 1 is 3, then you have 2x raised to the power of 3 over 3 plus 2x, this k plus k, that's constant plus constant is constant. There's no, it's not 2k plus what, a constant. So that is our answer. That is our answer. So you have 2x raised to the power 3 over 3 plus 2x. Like I said, if you want to have an in-depth knowledge of the integral calculus, feel free to go to the subjects by topic area. Just look for the integral calculus. We're going to break it down there. Then you come back here and see that the question is really very, very simple. Okay. Now, so if you look at your option, you have option A, 2x cubed over 3 minus 2x plus k. Option B says is x raised to the power 3 plus 2x plus k. And option C says is 2x cubed over 3 plus 2x plus k. That is it. Option C. And then your D goes ahead and says x raised to the power 3 minus 2x plus k. But remember, I always told you, it's a function of the concept, not A, B, C. All right. Now, question number 2. Question number 2 says, if the mean of 4, y, 8, and 10 is 7. If the mean of 4, y, 8, and 10 is 7, find y. If the mean of 4, y, 8, and 10 is 7, find y. So we have 4, y, 8, and 10. Their mean is what? The mean is 7. So we have to find y. Remember, your mean, which is your average, is equals to mean, and if you call it your x bar, is equals to sum of fx all over sum of f. Invariably, what we are saying is you multiply the variables by the numbers they appear, divided by the summation of the appearance. So what we are going to do is, now we have 4 appearing only one time. So 4 times 1 plus y plus 8 plus 10 divided by the appearance. 4 appear only once, that's 1, 2, 3, 4. Divided by 4, all is equals to 7. Okay, now what we have is 4 plus 8, 12. 12 plus 10, we have 22. So we have, this is equals to 22, 22, okay, plus y over 4 is equals to 7. So what we're doing there is, you have your 22 plus y to be equals to 4 times 7, 28. So your y is equals to 28 minus 22. So your y equals to what? 6. Okay. Now, so if you look at the option, you have option A says is 6, B says 10, C says 7, and D says 9. So your answer is A. All right. Question number 3 says, find the derivative of y equals to 1 over 3x plus 6 all squared. So we are having y to be equals to 1 over 3x plus 6 all squared. Plus 6 all squared. So we have to find the derivative of it. So what is this is saying in essence is find the y, the x. So this is under differential calculus. Okay, so point to note under differentiation. If you have y to be a function of x, which is same thing as a x raised to power n, where a is the coefficient of x and n is the power of x, then your dy ds equals to a times n x raised to power n minus 1. Okay, So what we do here is, if you have a function that has a coefficient and then has a power, so your dy dx is simply multiplying the power by the coefficient and reducing the power by what? By 1. Okay, so that gives us the answer. So this is going to be a n x raised to power n minus 1. An example of this is if you have 2s squared or 2s raised to power 3. If you are looking for the, if y equals to this, if you're looking for the dy dx of it, the y dx would be 3 times 2 s raised to power 3 minus 1, and this will give us 6x squared. Okay, just give you a background to that. So this one first thing to note on the differentiation. And another thing to know is this: if you have a function like this is actually a function inside a function. Okay, so what you need to do is you differentiate the first function here as an entity, then you differentiate the whole function as a whole. So what I mean is this: you know, this can be on its own, like 1 over 3x plus 6 can be on its own. Okay, so you differentiate this. When you differentiate this, the answer that you have, you keep it aside. Then when you differentiate the whole thing, the answer that you have, you keep it aside, then you multiply it together. All right, that is that. But before I go there, let me let you know that also know that when you differentiate a constant, when you differentiate a constant you have what? You have 0. So what we are saying is, if y equals to 6, for instance, 6 is a constant. Okay, 6 is a constant, and why is it equals to 0? 6 also have an x beside it. It's just that the x it's having beside it, it's having a power of 0, because any number raised to power 0 apart from 0 is equals to what? 1. So now if you are differentiating this, your dy dx will be equals to 0 times 6. You know, remember the what we have up here. Then this will multiply 0 by 6, then you subtract, then you have, this is x, then is 0 minus 1. By the time you multiply 0 by all this is going to be 0. So that's why each time you differentiate a constant, you always have what? A 0. So having this in mind, that when you do that, you have 0. Let me go to the next screen so you can have space to ourselves. Okay, so another point to note is what I said earlier on, that when you have a function inside a function, you differentiate one, okay, then you differentiate the other as a whole, then you multiply it together. So let's solve these questions that we have. It's very, very simple. You have y to be equals to 1 over 3x plus 6 all square. So this kind of question, when you have them and you are having an objective question, what you simply do is your dy dx will be equal to, when you differentiate this whole thing, okay, this one, when you differentiate it, you are going to have 1 over 3, okay. When you differentiate 1 over 3x, let me break it down further. So you take it as 1 over 3x plus c. Okay, so you differentiate that. So when you differentiate that, you have the first differential factor to be equal to 1 over 3. Okay, the y dx will be equals to 1 over 3. Okay, because this will be 0, and then this is 1 over 3, which is just beside of this, so you have 1 over 3 times, then you differentiate this as a whole as if it's x squared. You know, if you're having x squared, you just multiply this by the coefficient, which will be equals to something like 2x, and then you subtract the power by 1. So the same thing you're going to do here. You have differentiated what you have in it. So then you have 1 over 3. Then when you differentiate it as a whole, and you multiply 2 by the coefficients here, so you get times 2 times, then you write it again, 1 over 3x plus 6. Then you just remove this power by 1. That's 2 minus 1. Okay, so this is going to give us 2 over 3. Then we have 1 over 3x plus 6. Then 2 minus 1, 1. So you have it like that. So this is your answer. 2 over 3 into 1 over 3x plus what? Plus 6. Your answer is B.